Ever turned too quickly and walked straight into a wall? I have. It hurts and makes me feel dumb. We can blame the normal force for the pain we feel while running into solid objects. The normal force is the force that surfaces exert to prevent solid objects from passing through each other. So, normal force is a contact force, which is you have a block over here and this is the table. So if they are in contact, this is mg, that is the gravitational force on the block. The normal force will be perpendicular to the surface. So this is normal force. You can either represent normal force as n or Fn. So if the surfaces are not in contact, so there is no normal force acting over here. So the word normal and normal force is not referring to ordinary or commonplace. The normal here refers to perpendicular. So normal, the meaning of normal in geometry is perpendicular to the surface. So as we know Newton's third law, every action force has an equal and opposite reaction force. So if we keep a block over here on a table, there's a force that is exerted by the block on the table, that is mg, due to gravity. Now this mg, which is acting on the table, causes a small deformation over here, just like this, and this is so small that you can't see with your naked eye. So any surface, as you know, any surface which deforms, it has a tendency to come back to its normal position or normal state. So that when it pushes back, so the table pushes back, that pushing is the normal force. So this satisfies Newton's third law. So you need to know how to draw a force diagram. That is, this is the point, this is the normal, and this is mg. So this is how you draw a force diagram. Now let us consider a different case where you have a wedge and this is the block placed on the inclined surface. So just think for a minute, where will the normal be? Yes, the normal is always perpendicular to the surface. That means the normal is over here, like this, and the mg down. Now in this case, n is equal to mg. But in this case, we need to draw. So the components will be this and this. So if this is theta, mg over here, it is 90. So this will be 90 minus theta. So this angle is theta. So this will be mg cos theta. And this is mg sin theta. So therefore normal is equal to mg cos theta. So let's look at a simple sum. Over here we have a block which has mass m, and there's a slanting force applied on it, and the force is 10 Newton. And the angle to which the force is applied is theta. So now let's draw a force diagram. That is, this is the normal force acting, this is the mg, and this is F. So we have to draw the components of F. So let's draw it here first. Then this over here will be F sin theta, and over here it will be F cos theta. That means the force over here is F sin theta. So this is F cos theta. As we know, the normal is always equal to the opposite forces acting on it till the surface breaks. So over here we have normal is equal to mg plus F sin theta.
So as you can see over here, the normal force is not constant but can keep on changing depending on the force applied on the surface. Okay, and if this force applied keeps on increasing, then finally the material will break. In this case, this wooden table might break. Okay, but till the wooden table breaks, the force exerted upward by the table, which is the normal force, right, will keep on matching the force applied on the table in the vertical downward direction.